This conference will now be recorded.
If you go to the Open Compute website and look down a little bit on the front page, you'll see a link for the regional summit. This is a new thing this year. Traditionally there's been one summit per year, and that's been in San Jose or Santa Clara. And this year, for the European OCP enthusiasts, they're initiating this regional. That's going to be in Amsterdam, October 1st and 2nd. And it'll be a format very similar to the summit that we have here in Santa Clara or San Jose. It's going to be one day of keynotes, and I think there's a show floor where vendors will be showing off their wares. And then the second day will be workshops for each of the projects. And there'll be a workshop for the networking project. And so all of you who are in Europe or want to go to Europe and see Amsterdam, then you can attend the regional summit. I will be there, and I'll be sort of moderating the networking workshop on that second day. Anything else, Omar, you want to mention about the regional summit?
No, I thought it was just a public service reminder.
Yeah. Michael or someone from the foundation, do you know how many people will be attending? I guess there's no one there. I'm sorry, I think I talked over somebody. Go ahead.
I see Michael's online, but maybe if I'll message him, see if he can comment on that a little bit later.
Hey Scott, no, Omar. Sorry, I was talking on mute. The question was about summit attendance.
Yeah, I was just wondering how many people we've got signed up.
So I think our pre-registration numbers are around 350, and I know pre-registration closes within the next couple weeks. We're expecting between 700 and around 1,000, I believe. And again, just like with the U.S. Summit, a large percentage of folks show up day of. So I think Kaylee would have the exact numbers for you, but I think it's right in that range.
Okay. So we're expecting between 700 and 1,000 at that.
And I do know that the price does increase by roughly around $100 if you show up day of. So encourage you to register now. Save a little money there.
Yeah, it's actually 100 euros. So it's a little more than $100.
Oh, yeah. And I forgot about the exchange rate.
One more announcement, Scott. Sorry, I didn't get to coordinate on this. Before we start into the rest of the formal agenda, I think between our workshop in end of August and now, we had the OCP inspired acceptances from Delta Agama, right?
Yeah, that's right. So you want to talk about those, or I can put up the list here.
The wiki page.
Yeah. So I'm sharing the wiki page. I hope people can see that.
Yeah.
We have for the first time OCP inspired hardware. So this is, well, actually, Omar, you want to describe the difference between OCP accepted and OCP inspired?
Yeah. So this is something that we've been going through over the past, actually, I think last year or so, in terms of it was around a year and a half ago where we announced this concept of inspired, where there are some companies where what they want to do is they want to position and share the specification for their switches, but for whatever reason are unable to or don't want to share the whole design package, and so they start off with a specification, that gets reviewed by and presented to the networking project as well as to the incubation committee, and they go through review of it as well. And so it is hardware that is available, products that are built around that spec, but they are not with design packages, but they still satisfy the different tenets of OCP scale and efficiency and openness. And so these are the first switches that we've recognized with that inspired designation. And these are products that are available now within the marketplace.
Right, and so we thank Agama for those 5 and for contributing the specifications for those. And there is nothing that prevents a vendor from initially going for an inspired contribution and then later upgrading it to a full accepted design, like all the other ones we've had.
Yes.
And Omar, Scott, if I could just piggyback off that really quickly, since we are having that OCP inspired definition discussion, one important note is that only silver, gold, and platinum members of OCP are eligible to as OCP inspired and thus withhold the design files. Anyone can contribute something that OCP accepted, but OCP inspired is reserved for those 3 higher tiers.
Oh, yes, that's right. Thanks, Michael.
Yeah.
Cool. All right. So those are the public service announcements that I want to make sure we got in there.
Okay, so let's get on to the more formal part of the agenda, I guess we call it. And this is, first item is the OCP Networking Project Workshop that we recently held at Flex in San Jose. I think there was 70, 75 people. I just want to first say a big thank you to Flex. They were great hosts. And their facility was absolutely amazing. The food was amazing. So they did a really good job hosting. For those of you that were there, I'm sure you're envious of the big screens on the walls. Wish you had those at home. But anyways, great time, and big thank you to Flex. So then the other thing was we wanted to just do a quick around the horn wrap up of the workshop, just summaries by each of the leaders of the subprojects who presented and led sessions there. So that would be Kurt and Jeff and Shin. So Kurt, you want to start?
Sure. So yeah, I want to echo Scott's sentiments that it was a great bit of hosting there by Flex, and it was a wonderful facility and set of conference rooms. From the ONI perspective, what I did in the main session was I presented a quick view of ONI and then dove into a live demonstration of how to develop with ONI, how to build ONI, how to compile it, how to install it using a virtual machine, not physical hardware, but everything running on a virtual machine, how to install ONI, how to install a NOS, how to put ONI through in the presentation, which was really cool. It was fun. And then later in the afternoon, Jeff and I shared a conference room, and we went over the more educational aspects of ONI and open networking, where we just fielded questions from folks who wanted to know more about what is ONI or what is ONL, and what are some things that we can do with it. All in all, it was really cool. So yeah, that's it for my summary.
Okay.
And I put some notes. Down in the meeting minutes, I put some links to the slides and the video for those who want to check that out.
Oh, right. Good to mention that. For those of you who couldn't attend, the videos have been made available by OCP. So all the sessions, except for the afternoon session with Kurt and Jeff, all the sessions were recorded. so you can catch up that way if you couldn't attend. Jeff, are you on the line? If you are, you're on mute. Okay, so I'll just say for Jeff, as Kurt said in the afternoon, he did a session with Kurt where they went over ONL and you know, the sort of went around the room and addressed questions about ONL and its usage and what it's for. In the morning, Jeff gave a presentation about ONL, why it was necessary, what it does and doesn't do, and why you want to use ONL so to quote the good stuff of your networking device, the more important things like protocols and switching, and let ONL handle all the mundane stuff. And then also in the morning, we had Shin present about Sonic and also an SAI update. Shin, are you online?
Hi, Scott. Yes, I'm online. I am just logging as OCP4, OCP3. That's yeah. So you probably don't see my name there. Also echo Scott. A big thanks to Flex for hosting this event. Actually, I believe this is a very successful event. We have two sessions. In the morning, I give an overview of where Sonic is, how the release works, and giving two scenarios, user scenarios, to show that how the releases evolve, where we keep adding like more capabilities or more troubleshooting capabilities around RDMA and reliability part. That is fast reboot and warm reboot. In the afternoon breakout session, we deep dive into multiple fields. The major ones are general summarize of platform support once you enable hardware platform on Sonic. A very systematic view of all the peripherals, how we control it, and what's the API, and what's the plan for that. As well as another deep dive into the Sonic platform component, the relationship between them. If you need to enable like a component, for example, FRR, which are the parts you need to touch. This actually give people a deep feeling of how the architecture works, and particularly the relationship and dependencies inside this platform. Beyond that, we also have a live demo of gRPC on Sonic, as well as like a PTF test, a demo on PTF test that is for SAI to validate the SAI implementation, as well as Arkady from Belfoot talk about how to compile a Sonic image using different P4 compile P4 for different flavors. So basically, I think it's very well received. A lot of questions in the afternoon session. I do have a question for OCP staff. I checked the link that currently video of afternoon session. Most of them are posted, but there are two sessions missing. One is about deep dive into the Sonic components. The second one is the gRPC part. I wonder, is that we are still processing the videos, or it's not there?
Hey Shin, yes. So I'm actually still editing those this afternoon. I hope to have those up this evening.
Okay, great. Once it's done, then I will send to the community. Yeah.
Yep.
Yeah, I guess it's. Okay, great. Thank you.
You bet.
Oh, I will also send you the slides. You can link to it.
Oh, perfect. Thank you.
Thanks. Yeah.
Thank you, Shin. So Michael.
Yeah, looking forward to have more of this. Yeah, sorry, Scott.
Yeah. So Michael posted the link to the videos in the chat for the call today. The other thing we want to do is just kind of open it up here, and for those people who are present or watched it, just give us feedback. Good things, bad things. You know, we do these typically once or twice a year, and we want to make them the best that we can for everybody. And so when we get feedback, you know, we take that to heart and improve or change the summits or the workshops for the next time. So if anybody would like to make some comments, please do so now.
Let me throw out one. Yeah, I believe when OCP networking projects are growing, the community member are also growing. So one thing, I think the most thing I received the pin from the community is they cannot register after the capacity has been reached. The great thing is OCP recorded and published online. But also many people would like to participate because they would like to know the community and would like to ask questions that they have in person. So this is feedback that I received the most from people reach out to me, Sonic Kasai community, is that how can they have also the chance like to get registered, have a bigger room, or for the next workshop.
Yeah, that's good feedback. I know that it filled up pretty fast. Even though we had room for 75 people, we probably need to plan for maybe 125 next time.
Right. Yeah. Yeah, thanks. I think that's a good number. Yeah.
Go in and just sort of observed. I really enjoyed having you know, a couple of other companies talk about how they're using Sonic. I was sitting in on the afternoon session with Sonic, and you know, having folks from Alibaba and LinkedIn share their experience. Really, hopefully, we can get more of that across all the different groups. You know, obviously, we rely on Kurt and Jeff and folks from Cumulus and Big Switch and Microsoft to help drive these projects, but see the bigger community sharing their experiences, I think, is really valuable. So I'd encourage anybody who's using any of those other any of our software projects to chime in, you know, at future workshops. So thanks to those speakers as well.
Any more feedback that anybody would like to provide?
I see Robert liked the tour. The tour was good. It's neat to see that. Okay.
All right. So obviously, if you don't feel comfortable talking about it in this meeting, public forum, please reach out to Omar or myself, and you know, just send us an email or catch me at the OCP Regional Summit. Be happy to take your feedback privately. Okay, oh, my voice is going, I think. The next item is the a presentation by Jignesh about the flyover technology. So I will share or let him share his screen.
Yeah, I'm trying to share. Hi, this is Jignesh. And
Hold on. Jignesh, there we go. Make presenter. So, Jignesh, did you get a message that says you're now
Yeah.
presenter?
I did. It's asking me to download an extension, so I'm just doing that.
Yep. Okay, I can see your screen now.
Oh, you can. Okay, perfect. Okay, I'll go to presentation mode here. So first of all, I'm sorry about last month. I did not attend because I got confused about the time. I was looking at it from Eastern time rather than Pacific time. So sorry about that. Anyway, and how many minutes do I have, Scott? I'll pace myself.
I think we scheduled 15.
15. Okay, perfect. So this presentation is about modular architecture we'll talk about network switches, but it can be applied to other products as well. And that gets enabled by TwinAx copper cable. In this case, Samtec's TwinAx cable is called the flyover. So the agenda is going to be the discussion about the conventional architecture and some of the limitations of how the TwinAx cable helps with that, and how it can be used to do a modular architecture, and some demos that have been done earlier this year by Samtec. In conventional architecture, every design is unique. So if you have a different network switch or a different product, there's not many building blocks that are reused as far as beyond the components itself, right? As in, if there's a certain PCB, then every PCB is different, and it has to be designed. The signal integrity, everything has to be looked at in detail every time, and so there aren't too many building blocks in conventional architecture. The other thing is that as we are going up in data rates from 56 gig to 56 gig and beyond, the signal integrity is becoming a serious issue, especially for high density products. They're using in conventional architecture a lot of higher end PCBs, perhaps even retimers, and those the cost and also with limitations as far as performance is concerned. The same thing goes for thermals. As the data rates increase, the power consumption and the temperature sensitivity of a lot of the components has become critical. In a conventional architecture, in a network switch, what we'll have is the ASIC is going to be placed pretty close. It could be 350 watts or 500 watts, and that's placed pretty close to the temperature-sensitive optics, front panel optics, and that becomes a little challenging from thermal perspective. So there are two parameters that are kind of at the limit. One is the signal integrity performance, and the other is the thermal performance. In order to solve this problem, we have to give margin to any one parameter at least. And if you give margin to one parameter, then you can use that margin to perhaps re-architect your system so that you get margin in the other parameter as well. At least that's the thought process here. So the solution that we are proposing is a flyover technology that's using copper TwinAx cables. So in flyover technology, what we have is we have connectors on either end that are joined in by a TwinAx cable, TwinAx copper cable. Which connector we put on either end, that's actually, any of the connectors can be put on either end. It doesn't have to be like N1 doesn't have to be a QSFP or QSFP-DD. It can be any of the various connectors that we have, and same goes for N2. The TwinAx cable, for folks who are not familiar with it, it's basically it has two copper conductors with a dielectric around it, and which has a copper foil wrapped around with another, say, aluminum mylar, and then a jacket for preventing any cracks or damaging the cable. the key is out here is to make sure that the copper conductors are held very tightly, close together and precisely with respect to each other. And also the dielectric properties matter a lot. The way Samtec does it is we co-extrude the cable. That means both conductors are extruded, has the mold are extruded at the same time with the dielectric around it. As a result, we can hold the dimension between the two conductors very precisely. And there is no air gap in the dielectric or around the dielectric. As a result, when you bend the cable, the remains quite. So typical, we get around 3.5 picosecond per meter of skew. That's really low as compared to what's out there in the industry. And these cables are available in different gauges, all the way. Actually, we have 26 gauge as well. So from 26 gauge all the way to 36 gauge. I've highlighted 34 gauge here because for inside the box applications, you want to try and get away with the smallest or thinnest possible cable. The reason is that cable management and thermal management and all that becomes critical. So thick cable, like a 30 gauge, then managing the cables inside, say, a 1 RU type of box is going to be difficult. So you want to try, and if you can get away with the 36 gauge, that's even better. But 34 gauge right now seems to be the sweet spot for most of the applications that we are doing. The other is because we co-extrude the conductors, we can hold the distance between them, vary it on the production line very easily. So you can have an 85 ohm cable or a 92 ohm cable or a 100 ohm cable or anything that you would like extruded very easily. Now, the performance benefit of a twin-axe cable is, in this graph, if you look at the yellow, pink, and red, that's the insertion loss versus Nyquist frequency for PCB materials. The red would be the Mectron 7 type of material. And the red and the blue and the green are for a twin-axe cable. So the insertion loss for a twin-axe cable is significantly lower than the high-end PCB material. And the other, for each of the colors, you see a dotted line and a solid line. The dotted line is at 25C performance, and the solid line is at 85C. So for PCB materials, over temperature variation is much higher than that for twin-axe cables. So twin-axe cables gives two advantages: lower insertion loss and significantly lower over temperature variation. And this becomes the key reason why the signal integrity performance of twin-axe cables is better. Now, you take that cable and you want to attach it to end one. In this case, we are showing it how it gets attached to a QSFP DD. On the bottom right is just like a cartoon of what a conventional DD connector looks like. It has two rows of pins, and each row is of a different length. And also there are some 90-degree bends in the pins. In general, simplistically speaking, the signal integrity does not like 90-degree bends or complex bends. As we look at the image on the left, which is the flyover version, because we are having the twin-axe cables, they get attached directly to the contact pins. There are no 90-degree bends here. It's a straight shot. The twin-axe cable is directly connected to the contact pins, and to the contact pins. As a result, the performance of this connector is much better than the performance of the conventional QSFP-DD connector. The other thing that we've done is that the only cables the only cables we use are for the high-speed signals. All the power and control lines are press-fit pins into the board. There are two reasons for this. One is that cable management is difficult, has to be thought through, and it's a little involved as it is. So you want to minimize that cable management. And the other is, if you take power through another cable, then you have to worry about the I²R losses through that. So for these two reasons, we've chosen to have press fit pins for power and control lines. On the other end of it, we have a variety of connectors. We've kind of broadly broken them up into vertical and horizontal connectors. And depending on the application, you might, if you have a certain footprint requirement, a certain data rate requirement, or a certain height requirement, you could choose a different N2 connector. So we have connectors all the way from 28 gigabits per second, all the way rated to 56 gig NRZ or 112 gig PAM4. As you go from left to right, the performance kind of increases because on the left, the mini edge card cable and the edge rate, they are where the cables get terminated to a transition PCB, and the PCB goes into an edge card type of connector. This transition PCBs are is where you get some performance hit, and that's why they are rated at 28 gig or at the most at 56 gig PAM4. Now to get to the higher performance, what we've done for the XMAX and the Accelerate and the NovaRay is that we've eliminated the transition PCB. The cables are directly connected to the contact pin itself. That is one of the main reasons why those connectors are rated at a much higher data rate and a much higher performance.
I'm sorry, can you repeat that again about the higher performance and what's eliminated? I missed that. I'm sorry.
Oh, okay. So if you look at the left two, the mini edge card cable and the edge, those two are they have a transition PCB, which means the twin-ax cable is soldered to a transition PCB, and the transition PCB has plugs into an edge card type of connector. That transition PCB ends up getting a hit in performance because when you have to terminate a cable to a transition PCB, you have to bend those inner conductors and solder them down, and you get a lot of performance loss there, plus some loss in the PCB itself. Whereas in the other three on the right side, there is no transition PCB. The cable is directly connected to the contact pin itself. Very similar to how you see it in the QSFP-DD connector. The QSFP-DD, you can see the cable is soldered directly to the contact pin. Does that answer your question?
I think so. Could you go back to your previous slide on the connectors? So on the left-hand side, you have the PCB. I guess there's a connector in both situations. So they're both serviceable. Is that correct?
All of them are serviceable. So all of them can be plugged in and have a latching mechanism.
Mm-hmm. Okay. Yes, that answered my question. Thank you.
So if you look at a complete chip-to-chip, the insertion loss budget, for 56 gig PAM4, the VSR spec is around 9.4 dB from the chip all the way to the DD module. If you use one of our, which is a NovaRay connector with an 18-inch of copper twin-ax, 34 gauge copper twin-ax cable to our DD, then you get a 6.4 dB of insertion loss. So there's a margin of 3 dB. So you get a 3 dB margin here and you get a 3 dB margin here. This is assuming there is a 3-meter copper cable, DAC cable outside. And this is the margin that I was talking about, that if you have margin in one parameter, you could possibly use it to architect your system slightly differently such that it solves your other issues, which in this case could be thermal as well. So you end up getting 6 dB margin. That margin can be used many ways. One is you could run your chip at a low power. Maybe you can turn off some of the equalization, or if needed, instead of going with the 3-meter copper cable, you could possibly go up to 4 or 4.5 meter of external copper DAC cable. So there are different ways that margin could be useful. So back in at the OCP San Jose, we showed this demo where we took the we demonstrated a 12.8 terabit OCP wedge switch. This demo was done in collaboration with Marvell, and so the silicon that we're using, the ASIC that we're using is the Marvell silicon, and we have what you're seeing here is a OCP wedge switch that has been re-architected to be with a flyover cable. So this is 18-inch of flyover with a 3-meter DAC cable in some ports and 1-meter loopback DAC cable in other ports, and again 18 inches of twin-ax back to the chip. And we had 32 QSFP DDs, and the bit error rate that we get with that is as good as 1 e to the power minus 12 prefect. There was another demo which was the exact same switch and the stack up, but except without flyover, which is the standard conventional design. So it's a very good apples to apples comparison, and for that conventional design, the bit error rates were anywhere from 1e minus 3 to 1e minus 7. So this shows this was a very good comparative solution between what a flyover solution give you versus a conventional design. And so we showed this demo at San Jose, and we'll be showing this again in the regional summit at Amsterdam. And this demo is in our Santa Clara office. So for those of you who are in the Bay Area or are visiting the Bay Area, if you'd like to come see it, you're always welcome. Just reach out to me. But the question that's always asked is, okay, fine, we get it that the SI performance is very good, but look at this mess of cables, right? As in, in this case, I've taken this 32 QSFP and put it outside the OCP wedge. So how are you going to fit all these 512 cables into a switch box? And even if you manage to fit them, won't the cables block airflow? And the third one isn't a cable solution an expensive solution? So the answer to that is now coming to the main topic, which is modular. Given that, as I said, we have to think slightly differently in order to incorporate this into a meaningful solution. On the left is the standard OCP wedge design with a single high-speed PCB with 32 QSFP ports and an ASIC right near it. In the modular architecture, what we've done is we've taken the ASIC and pushed it further back. There are two advantages to this. One is a longer cable is actually easier to manage than a very short cable. If you have a cable that's only 4 or 6 inches long, it's actually a little difficult to manage because you're trying to get some bends in the cable. You won't have any slack. So if you get cables which are anywhere from 8 inches all the way to 18 inches, it's easier to manage. So one advantage is cable management. Pushing the ASIC back has it. The other advantage is that you've taken your power-hungry ASIC and moved it further away from your temperature-sensitive front panel QSFP-DD. As a result, the thermal performance of the system is much better than that of a conventional design. And the modular part of it is that now the only PCB that needs to be high speed is the one that's holding the ASIC. And there's no reason for that to be a single PCB. There's no reason for that to be the same PCB as that's what is holding the QSFP-DD or the power and communications board. As a result, the high-speed PCB can be 1/4 or 1/5 the size of your entire conventional design PCB. And all the other ones can be simple FR4s. The ones that's holding the QSFP-DD can be FR4. The power and COM modules, those can be simple FR4. So there's significant cost savings that can come from that. The other advantage is that you can take this this module, which is the ASIC module. In this case, it's everything connected to the front to QSFP-DD, but in case you had some other architecture in which some of it is connected to the front, some of it is connected to the back plane, like an XMAX connector, then we have cabled XMAX as well. So you could use the same high-speed module, ASIC module, and use it in different architecture. This view here shows the cross-section view of this. So these are the QSFP-DDs that are belly to belly, and this is the ASIC. The cables are the blue ones that are managed in the middle portion of in the center of the cross-section, and the airflow is on the top and the bottom. The reason for this is because this is belly to belly, the QSFP-DD heatsinks are on the top and the bottom, and the ASIC heatsink is on the top. There's a cable tray. One of the next slide will show. There's a cable tray that holds these cables, and the height of the cable tray can be adjusted so that you can increase the pressure drop as desired on the bottom side. The airflow on the bottom side needs to cool only the DD, and so it can be lower, and the airflow on the top is going to cool the DD and the ASIC, so you want higher airflow on the top. So you can modulate that airflow using the cable tray. As a result, you can get very uniform temperature distribution across all your 32 QSFP-DDs.
Jignesh, this is Scott. Just a time check here. I think we have one more presentation to go, and you're a little bit over. So,
okay, I'm sorry. Okay.
Well, I did one thing I wanted to say was that you are going to talk about this at the European Summit. So this is a great preview.
Okay.
And if you just want to wrap up real quick.
Yeah, I will. Sorry about that. And so we have demos for cable management and thermal management to show how this works. They're all working demos, and there's some more discussion on how this can be a cost-effective solution. And we're already seeing applications of this at 56 gig PAM4 already applied, not for the full 32 channels, everything flyover, but at least half of them to be flyover. We're already seeing that. And look forward to, if you have any questions, just reach out to me and I'll upload this presentation. Thank you.
Great, thank you. As I mentioned, if you want more details, we will post the presentation. Jignesh is available for questions, and he will be at the European Summit, where he can go into even more detail about this in a longer talk. So thank you.
Thank you.
Our next presenter is Jeff. Let me enable him. All right, Jeff, you should get a message now. And EdgeCore is going to be contributing a couple of switches based on new silicon. And this will also be part of the European Summit. Okay, Jeff, I can see your screen, but I can't hear you.
Oh, let me take myself off mute. It's all work here. Hopefully my PC will cooperate. Okay, I know we're short on time, so I'll make this quick, but if there's any, let me know. So yes, we plan to contribute a couple designs based on Trident 3 silicon from Broadcom, and this is an overview of what those contributions will look like and what the timeline looks like. So first off, just so everyone's aware, the contributions are made by EdgeCore Networks, and EdgeCore is a wholly owned subsidiary of Acton, and Acton's been around 35 years making networking products. So the what are we doing? So you know, we're updating or upgrading some of our current contributions through doing new product contributions. So we currently have Tomahawk and Tomahawk Plus based products that are contributed to OCP. These Trident 3 based products are very similar in form factor, and you know, they're kind of like an upgrade to those existing contributions that we have. Some of the enhancements of Trident 3 are listed here as compared to the Tomahawk and Tomahawk Plus variations of silicon. Briefly, I'll just go through them. It's a programmable pipeline for the Trident 3, although not P4 programmable. It is a programmable pipeline in this ASIC. It's got a 32 mega packet buffer compared to, you know, 20 some odd meg in the Tomahawks. It has MPLS enhancements for a number of labels that can be pushed and popped. Supports IPv6 VXLAN, which the Tomahawks not. And it has, you know, 2x the route table and 2x the ACL table size increases compared to the Tomahawk and Tomahawk Plus. So those are some of the, you know, high level of reasons why someone may choose a Trident 3 as compared to a Tomahawk based product. So the current products based on Tomahawk, we have a 32 port 100 gig switch, so 32 ports of QSFP28, your standard system LEDs and console and management ports. So pretty, you know, standard design for the 100 gig switch. And for the more of the top of rack 25 gig connectivity, you know, we have a switch based on Tomahawk Plus today that has 48 ports of SFP28 with 6 P28 uplinks, so 600 gig uplinks. QSFP Plus is a typo there, the QSFP28. So those are the two switches today. And so what are we replacing those with, or not replacing, updating those with new contributions? So we have two very similar form factors based on Trident 3. We have a 32 port QSFP28 switch, and we have a 48 port SFP28 switch. One of the main differences in these switches are there's 2 additional SFP plus ports for 10 gig connectivity, in addition to the standard networking ports. And on the 25 gig variant with the 48 ports, there's 800 gig uplink, the 6 uplinks in the Tomahawk version. These come with all of our standard CPU modules, so Intel x86 Atom class, Xeon class, and a new Denverton-based x86 CPU module can be ordered with these SKUs. Again, just quickly looking at the 32 port QSFP-DD, it's pretty straightforward design. A block diagram of that. One of the differences between the current and this product are these 10 gig ports here. So there's 2 10 gig ports on the ASIC, and there's 2 10 gig ports on the CPU. And there's a MUX function included in this design, so you can manipulate how those ports are directed, either, you know, front panel or CPU connectivity for those 10 gig ports from the ASIC. So that's kind of different in these designs compared to the standard Tomahawk designs. The second contribution is the 48 port 25 gig switch. So those 48 ports can run at 25 gig or 10 gig, of course, with 800 gig uplinks. Again, it has the 2 SFP plus ports, which are, you know, in addition to this design. Standard console management. This one has, in addition to the RJ45 console, a micro USB console port as well. And again, block diagram looks very similar to the other one, except the way the ports are broken out here on the front between SFP28s and QSFP28s. So what is it we're contributing? So we're contributing the design specification. We're seeking OCP accepted status. So we're contributing the complete design package, which contains all the standard stuff listed here on the slide, you know, so full schematics and Gerbers and the board files and all that stuff that goes along with it. And our software, we contribute in source format and also binary format for any CPLDs or FPGAs that may be on the boards. And a schedule. So the overview is what we're doing now on these contributions. That's available today. The design specifications are on the server. So I believe Scott and Omar just need to get those to the wiki, and those can be available, either today or sometime this week, because they're posted from my end. So those are available. And we plan to have the entire design package that we went over in the previous slide all up on the servers and ready for IC review by the end of September, so prior to the summit in October. So that's it. If there's any questions, I can certainly take them at this time. If not, then we can spend the rest of the time on whatever other matters we have.
Jeff, this is Harry Quackenbos. I have a question. At least one of your slides was marked confidential. I wasn't paying attention to all of them.
Ooh, I'm sorry. If it was, I will correct those and redo that.
Thank you.
Yeah. Thank you for catching that. That was not the intent. All right. Well, thank you.
Jeff, one more thing, Jeff. Robert asks, when are they available?
When the slides or the products or
No,
both?
I think he's asking about the product.
Products are available today, so we have samples out to, software partners that are porting their software. As far as able to order and buy one, I think those should be available now, but I have to check exactly on when they're available. But I know we're building these as we speak.
Okay, thanks.
All right, thank you.
So I think that pretty much comes to the end of our agenda. Since we just had the workshop, I think the status of most of the sub-projects has been pretty well covered there. And I think we can end the call at this point then, unless somebody else has something they'd like to bring up. Okay, great. We will see you all next month at the summit.
All right.
Thanks a bunch, Scott.